Now let's talk about the final stage. We've already constructed the model using all the tools provided by Inventor and Woodwork for Inventor. And of course, the final stage is to generate the information needed for both production and production management. One of the most important tasks here is generating various types of specifications. To better understand what kind of information is involved, let's start with a few introductory words about the type of data that Woodwork for Inventor generates. Understanding parts and blanks. First, it's important to understand that Autodesk Inventor is responsible for geometry creation. It builds the geometry, which we refer to as a part or part item. However, in the furniture industry, the term part has a broader meaning. It's often perceived as an assembly. In other words, from a furniture designer's perspective, the same model contains internal composition elements that we usually don't model because doing so would take a lot of time and significantly overload the model. For this reason, Woodwork for Inventor is capable of interpreting the same model in a completely different way. Primarily, it sees the part as having a base blank that carries the overall shape, and it can also have a number of covering blanks. Each of these blanks has its own material. So, while Inventor sees a simple part, Woodwork for Inventor internally breaks it down into several blanks, where each one can have its own material. As a result, we can provide much more detailed information about the part than what is available within the Inventor environment. Additionally, based on the created geometry, Woodwork for Inventor automatically calculates the dimensions of all blanks, as well as the part itself. That means the designer doesn't have to sit with a pencil in hand trying to extract dimensions from a drawing. This is especially important in the furniture industry. Materials, coatings, and dimensions. If we take another look at the model created in Inventor, we can first assign Woodwork for Inventor materials to it, which begins to differentiate it from the plain Inventor model. Moreover, we can assign various coatings to the model, such as edge bands, veneers, paints, and so on. The Woodwork for Inventor software is capable of recognizing and distinguishing between all of these. When we talk about information containers, it's important to note that Woodwork for Inventor can calculate the blank size. For example, if a part is covered with the edge bands, the blank should essentially be smaller, assuming no additional allowances or changed grain directions, because the thickness of the edge bands must be subtracted. Meanwhile, the part dimensions include all the coatings. This means we already have at least 2 sets of dimensions, which differ and must be reflected in the specifications. If the part is made from a board with a defined grain direction, that grain direction becomes very important. Depending on the grain, we might get completely different blank dimensions compared to when it's calculated just geometrically. The user has the ability to control the grain direction, and with that, control the blank size. Technological allowances. In addition, if there's any technological processing involved, simple dimension calculations are not enough. A technologist or another person responsible for finalizing the production data must be able to assign additional allowances for processing operations. These allowances are also reflected in the specifications, for example, when cutting is involved. This way, we leave a technological allowance for further operations. So, the blank size may change not only due to geometry, but also because the user has added these necessary allowances. Report generation with BOM generator. That's the theory. Now, let's take a look at what kind of information is actually generated in reports. Report generation using the BOM generator is based on a template system. The user can create custom report templates, which are generated in a specific format. We can have many templates depending on the target production site, and any user can edit these templates. The principle is simple. In Excel, we create tables with specific keywords that define what data goes into which column. This allows us to create various custom report formats. Let's now try launching the standard template included in the software package and see what information it generates during this process. One of the most commonly used specification types is the so-called structural specification, which reflects the same structure we see in Inventor. It is hierarchically connected and includes part dimensions, quantities, materials, and so on. Another widely used specification type is the cutting list, used primarily when importing data into cutting optimization software. For example, We often use this format when importing data into the CutWrite program. There's also the Material Summary Report, which shows how much of each material is needed to manufacture the entire product. It calculates total quantities and is typically used either by the procurement department or for cost estimation purposes. Real-world applications. Here's some real-life examples from our clients, who use these same templates to generate all kinds of reports tailored to their specific needs. This flexible approach allows us to organize information efficiently, both for people and for various systems that rely on this data.